Yep, sounds good. Is the microphone on? Great. Hello, everybody, and welcome to Build. I hope you've had so much fun so far seeing cool stuff, and I hope that you will continue having fun after this session. My name is Anush Saburi. I'm a program manager with OS Security, and today, alongside Mike Stevens, we're going to talk to you about Microsoft Passport and Windows Hello. Windows Hello is a new biometric authentication in Windows 10, and Microsoft Passport is what is going to replace your passwords moving forward. So Windows Hello is a biometric authentication that allows you to have immediate access to your Windows 10 devices. With Windows Hello, you can use your face, scan your finger, or scan your eye, and be able to immediately recognize. Windows Hello supports application authentication. It can be used to access enterprise contents, and it can also be used to authenticate within the browser experiences. Windows Hello obviously provides a much more personal experience compared to passwords, but it's also more secure. The security of Windows Hello comes from a technology called Microsoft Passport, which I will talk about in the second part of the presentation. Suffice to say that Windows 10 supports 3 types of biometrics: fingerprint, face, and iris. All these 3 are recommended on all the devices with the supporting hardware. And if you're a developer that is working on a biometric experience, we recommend that you actually integrate with Windows biometric framework that allows your application to leverage the Windows end-to-end experience for enrollment and usage, and also provides the same design language that the users are accustomed to. I think the best way to actually see Windows Hello is via a demo. So I think I'm just going to switch to this other computer that is sitting here. It is a laptop that I have already enrolled my face into it, and I will show you how Windows Hello is tightly integrated to the device unlock experience. So let me switch to that device, and let me lock this device. So the first thing that you notice is a new kind of feedback language on the lock screen. As you can imagine, we won't have the camera on all the time to scan for faces, and we only do that when we know the user wants to get authenticated. And when we do so, we actually provide that kind of feedback to the user. So what you're seeing right now is the PC telling me in a very cute way that it's looking for my face. You see that's kind of a small eye on top that is scanning around and looking for my face. One thing to keep in mind is that the same design language is actually used for other biometrics. So for example, if I'm using my finger to authenticate to my device, and let's say I scan the wrong finger, the same feedback language is used to say the finger you just used is not recognized. For example, if I have to move my face away because it's too close to the camera, same language is used to provide that feedback as well. So it's a very personal experience. It makes the PC way more closely to what users expect. So what I'm going to do next is to actually uncover the camera, and you can see that how fast it would be to get authenticated. So as soon as I bring my face, voila, logon happened. So as you can see, this is a very, let me switch back to, as you can see, it's a very streamlined experience. It's very personal. The learning curve is very fast because we tell the user what to do. It's in a way that doesn't need them to do any extra work. Now, the authentication with Windows Hello is not only limited to unlock your device. As I mentioned earlier, it can also be used in application authentication. And what I'm about to show you in the next part of the demo is how Windows Hello can be used in authenticating the user when purchasing an app. So let me switch back to the device that I was using. So here, I have launched the store app, and I'm ready to buy a movie. Sorry. OK, so the movie title is there, Horrible Bosses #2. And as soon as I click purchase, what you will see, let me cover the camera. What you will see is that I'm going to be asked to provide my Windows Hello biometrics here. I have the option of using my fingerprint or continue using scanning my face. So let me bring this up so you can see again, the same design language is also used here, telling me that the camera is on, it's looking for my face, and as soon as I bring my face in front, I get authenticated, and this prompt comes up that says, are you sure you want to purchase this? Stating that I don't have a credit card on file. I didn't want to spend $15 to buy the movie right now, but you get the idea. All right, so let's go back to our slides. So this is basically the kind of experience you could expect with Windows Hello. It's very personal, it's very easy to use, but obviously improvement of experience was not the only goal we had in mind. We want to make sure that your experience still preserves your privacy and is also secure. From a privacy perspective, we want to make sure you know that Microsoft never stores an image of you either on the device or on the backend server. We never ever send the enrollment data to the application or the server that is trying to authenticate you. And more importantly, we never update your enrollment data without your consent. In other words, if you say you're in a room with a lot of people, we don't want to to use the other faces in the room to update your enrollment data, which means that your experience or the reliability of your experience will be hugely reduced. You're always in control. You can visit the setting page and you can enhance your enrollment data. You can also remove your enrollment data if you wish, but we never do this automatically. So that's basically privacy. From a security perspective, our goal was to meet the enterprise-grade security that is required by many of our customers in the sector of government, financial sector, health sector, or defense. And what we have successfully demonstrated is that our algorithms meet the false acceptance rate that is required by such organization. False acceptance rate is the likelihood of somebody having random access to your device and being able to authenticate as you. Obviously, we want to make sure that the number is low. The target was 1 over 100,000, which we actually successfully achieved. Now, keep in mind that one could achieve a number of 0 if you never ever let anybody in, right? And that still gives you a 0 false acceptance rate, but it's not usable. So there is another rate that is tightly coupled with this false acceptance rate called the false rejection rate. Basically, that denotes how reliable and how user-friendly the algorithm is. This is the likelihood of me being the actual legit owner of the device, being able to actually authenticate and unlock my own device. So obviously, we want to make sure that the likelihood of that not happening is very low, and that's what this rate is about. So we have demonstrated that with the 1 over 100,000 false acceptance rate, the false rejection rate is between 2 to 4%. So the likelihood of me being able to finish my authentication experience is actually very high. The other things in terms of security is that we provide liveness measure, making sure that the user is physically present in front of the device. We also provide anti-spoofing mechanism with Windows Hello. In the lower part of this PowerPoint, you'll see that when you hold a picture of you in front of the camera, because we're using IR technology to scan the face, what the camera sees is basically a white picture of you. There's nothing that it can register with. You can also have the same experience if you hold your phone or your tablet in front of the camera. As you can see, they don't provide any data for the sensor. So it's a technology that is pleasant to use, it preserves your privacy, and it still meets the security requirement that is set by one of the most strictest requirements that is set by our customers. In terms of device support, all of the current and future fingerprint sensors will continue to work with Windows Hello. For face, all current and future Intel RealSense 3D cameras will be supported with Windows Hello. And in general, any device with an IR sensor that meets the published specs that we have will be supported with Windows Hello. For Iris, there will be a set of devices coming in the market within the next 12 months, but more details on the actual sensor requirements and the support will be coming soon. So as I mentioned at the beginning of this discussion, Windows Hello provides a very fluid user experience for authentication, but it's also more secure compared to password. And I also alluded to the fact that the security of Windows Hello comes from Microsoft Password. So in the second part of this talk, what I want to do is to actually walk you through of what Microsoft Passport is and how it's going to replace passwords moving forward. So Microsoft Passport is a technology that is based on the two-factor authentication we have been doing in enterprise for a long time. And the goal that is set for it is to provide a way to get rid of passwords in the internet. The problem with the passwords are inherently insecure and hard to use. There are so many passwords that you have to remember, which makes it humanly impossible to remember. And as a result, users start reusing the passwords across different websites. And what that means is that the user is now vulnerable to attacks of, like, if one server gets compromised, then their passwords are actually leaked. The chances of the same password being used on a different website is also high. So even if the other website is super protected, you're basically being compromised. So what Microsoft Passport does is solve both problems in one shot. It solves the user experience by replacing all of your passwords with only one 4-digit PIN that you have to remember that is actually the device PIN as well. So you use the same PIN to unlock your device. Now you can use the same PIN to access your contents and applications. So it's much easier to remember. Moreover, it can also use Windows Hello for user authentication, which means that there is nothing for you to remember. It's really natural. Now, you may ask, how could a 4-digit PIN be more secure than a password? And I'll explain this later, but suffice to say that knowing the PIN is not enough to access your account. The attacker actually has to have access to your device, which makes it more secure. So that solves the user experience problem. The second problem with the password was the server attacks. With Microsoft Passport, because it uses the asymmetric cryptography technology, there's no reason to store any secrets on a server. So even one server gets compromised, there's nothing in there that can be used to attack you on other websites. And this is what we call it a two-factor authentication, because your device contains the private key of the kind of the public key pair that is used for your authentication, plus the PIN that you know. So it's two factors, something you have, your device, and something that you know, your PIN, or something that you are, your biometrics. So it provides a two-factor authentication for the user. Our goal that was set with Microsoft Passport is to provide strong user authentication for everybody. We started with our own products, with our own identities, including Azure AD, On-Prem AD, and Microsoft account, and we're proud to announce that they all will be supporting Microsoft Passport at the release time. We've also tried really hard to provide really easy access for developers to use this framework, kind of taking our understanding from strong authentication in the enterprise sector and bring it to the consumer. And Mike will walk you through on how easy it is to use this framework. Moreover, we have joined FIDO Alliance, which is a group of companies that care about user authentication, and they want to move it to a place that is much better than password. And we want to make sure that the Microsoft Passport will be the reference implementation for FIDO 2.0 specs. What that means is that there will be a variety of devices that the user can pick to store their private key outside their own device. And that provides an option for them to customize the experience that they want to have for their authentication. So that basically gives strong user authentication for everybody. The value prop of Microsoft Passport for developers is also huge. With Microsoft Passport, the costs that are normally associated with the passwords go away. For example, the password compromises. That whole thing is going to go away. Users forget their password. You have to define a flow for them to reset that. That also is not necessary, because with Windows Hello, there's nothing to remember. Also, with passwords, servers have to take extra steps to secure storing them on their server. It's a sensitive data. And whenever you have to do stuff like that, that means that you have to spend more money. With Microsoft Passport, you're simply storing public keys. There's nothing secret about it. You can even publish them. There's no problem with that. And that's basically another reduction in terms of the server deployment. From API support, as Mike will walk you through, we have now native API to do strong user auth, which is fully integrated with Windows Hello. And soon, later this year, we'll have support for JavaScript API. Our involvement with FIDO would allow us to come up with a standard set of JavaScript APIs that also works across other browsers, so it's not something that only IE will support. So that's basically the value prop for developers. And for users, well, It's basically the concepts that they're familiar with. The way they see Microsoft Passport is a simple 4-digit PIN, or using their biometrics through Windows Hello. And the way these kind of gestures, if you will, are set up is for PIN, we do this at the time of device setup. So when the user buys a device for the first time and they're setting it up, they'll see a very simple experience to set up a PIN. For Windows Hello, they can do this after the setup by visiting the setting page. I will show you what the experience will look like at the time of device setup to set up a PIN here. So in this case, the user just simply bought a new, let's say, tablet or a new PC, and they see this page that allows them to use Microsoft account to authenticate. So they provide the username, password for their Microsoft account, and they'll see a new page that says, hey, passwords are still yesterday. We've moved to a new technology. It's called Microsoft Passport. And the way we tell this to the user is set up a simple 4-digit PIN, and trust us, it's more secure than password. There's a link in there that explains why a 4-digit PIN could be more secure than a password, which I will get into later. If the user agrees to this, they'll see a simple set up a PIN. They type in a 4-digit PIN. If they wish to take a longer PIN, they can also do that. And at this point, Microsoft Passport is set up. Throughout the demos that I showed you, whether it was unlocking my device or purchasing an app with Windows Hello, what was actually happening on the back end was that Microsoft account was using Microsoft Passport for authentication. So in none of those flows, my Microsoft account password was being sent over the wire. Everything was based on asymmetric key operations. So let me go back to the same device that I showcased the store purchase and show you what it means to have PIN set up. Okay, so let's try to buy this app again. So previously you saw the Windows Hello gestures, fingerprint, or face. As you can see, there is an option for PIN, right? And this tells you that all of these gestures are equivalent when it comes to authenticating the user. And the user can decide which one to use depending on the scenario they're in. Go ahead and cancel this. All right, coming back to here. So I talked about this at the beginning of this part of the presentation as why a 4-digit PIN is more secure than a password. So by now, I think you have a better idea of how this works. So there is an asymmetric key that is generated on a device that is protected by the PIN. So for an attacker to actually attack you, they have to know the PIN that you use and also have access to the device where your private key resides. So that means that the attacker has to have access to 2 factors rather than only your password, and that's why it is more secure. Some extra crypto knowledge here wouldn't hurt. Microsoft Passport supports talking to a security module on device called TPM, or Trusted Platform Module. TPM is an interesting device because it provides some really nice properties for Microsoft Passport. First of all, it supports what is called an anti-hammering. It protects against brute forcing your device to figure out your PIN. So if somebody has access to your device and want to guess your PIN, it will slow them down tremendously. The keys that are protected by the TPM are impossible to be stolen from that device and replayed on a different device. So that means that if you have a malware running on your system, they cannot simply harvest your credential and replay it on a different device. The other thing to keep in mind is that the PIN is never stored on the device or the server. So if somebody has physical access to your hard drive, there's no direct way for them to figure out your PIN. All right, last slide on the crypto. This is actually the way I normally visualize Microsoft Passport. The way I think about this is as a folder containing a whole bunch of keys for different accounts that you may have. And this folder is locked. And for you to unlock it, or for any app to unlock it, a user gesture has to be provided. This user gesture could be a PIN, could be a swipe of their finger, could be a scan of their iris, or could be their face. It doesn't matter. They're equivalent. If you remember from the store purchase, they're all presented to the user at time of authentication. Once the user provides the right PIN or scan the right iris, the folder is now unlocked. So the app has now access to its key. what we make sure is that there's a separation between these keys, right? So if two applications, foo and bar, create key in that folder, we make sure that none of them can access the other key. We also make sure that these two applications cannot collude together and try to figure out or map the users together. So if you have foo at foo.com and bar.com, there's no way for these two servers to figure out they're tied to the same user. So that's a kind of an overall summary of what Microsoft Passport is and how it looks. Let's summarize what we have seen so far. So we started with introducing the experience with Windows Hello and how the user will use it to unlock their device and perform application authentication like store purchase. Then I'll walk you through about how it is more secure than password. We talked about Microsoft Passport and how the keys are stored in it and all the crypto that is sitting in between. In the third part of the talk, and this is where I would invite Mike to come to stage, is we're going to tell you how you as developer can leverage this framework. As you can see, it's very simple. It's basically 3 APIs you need to call, and you get all the experiences similar to store purchase. So with that, I'm going to pass it to Mike. Thank you for your time.
Thanks, Anush. How's everybody doing? Cool stuff here at Build. So as Anush said, we've introduced to you this new thing called Windows Hello, which is our biometric framework. And we combined it with Microsoft Passport to give you a very personal, but yet a very strong user authentication that we hope you'll choose to use over passwords. Now, in Anush's presentation, we showed you how Microsoft Account, which is our identity, has incorporated Microsoft Passport and Windows Hello into their technology, into their software. So this last section of this presentation is we want to show you, the developers, how you can take this technology and easily incorporate it into the apps that you're going to be building for Windows 10. So in this particular, let's start, the best way to do this is just show you an app that we've developed. And wake up. And this is a demo app that we've created, and we've taken the APIs that you're going to use, incorporate those into your app. So this is a simple little Microsoft Dynamics expense kind of app that we've created. And as you can see here, we get to the familiar username and password prompt. Now, the username and password prompt is today's story. And so unfortunately, we can't just jump straight into using Microsoft Passport. So we have to use the traditional way of authentication right now. So in this particular app, what you'll see me do is I'm going to go ahead and type in my username. And then I'll type in a very long password that I barely remember. And so, as you can see in this particular app, I have two options here. I can do start using Microsoft Passport or sign in. Sign in is the traditional password authentication that we've been using for the last 10, 15 years, right? But what I can do is I can say, hey, this app's giving me an opportunity to upgrade to something more simple and more secure. So with that, what I'll do is I'll actually tap the start using Microsoft Passport. And what you're seeing in this demo is actually the same user experience that you saw in Anush's slide where Microsoft Account. It's now asking me to use my fingerprint to create a Microsoft Passport, and these are actually the asymmetric keys that Anush spoke of. So in this particular case, I will take my finger, place it on and you see I've authenticated with Microsoft Passport using a fingerprint. Again, as Anush said, these gestures that we have is whatever biometric that it combines with the Windows biometric framework. So this is how we can do an authentication experience with using Microsoft Passport, and you get Windows Hello for free in it. So let's take a look at what actually took place in that app. So let me switch back over to our PowerPoint. So this is the actual flow that we use when we're going to do what we call provisioning. Now, as I said in that last, in the demo, I authenticated using my password because that's what we all know and do today. So ideally, the guidance here is after you've done your traditional password authentication and you upsell that user to, hey, there's a more simple, more secure way of signing into the app, we encourage you to use what we call a two-step verification process. And there's really, Microsoft Passport doesn't confine you or insist that you do that. This is just a guidance that we suggest to where you either send a text message to the phone, it gives them a code to type in, or you send a security question to the screen to make sure that the user who's enrolling in this new experience is actually the user who's actually owns this particular account or identity. Now, the great thing about this is that once they've done this, then they go to create the Microsoft Passport. And here's the great thing. As Anu said, Microsoft Passport is bound by asymmetric cryptography. What we have here is we have the workhorse of the API that you're going to use in the Universal Windows platform. It's the Key Credential Manager static class that we're providing with Windows 10. And in this static class, we create a method called request create async. This is the API that you use in your apps to create a Microsoft Passport key set for your application. The simple thing about it is we pass an account ID, which can be any kind of string that's familiar or works with your application. You can then take this account ID or this string and you can persist that in your application's data because it's not really a secret. Only your app can open it because of the key isolation that Anu spoke about. But what it really does is it makes a simple way for you to retrieve the key later without having to worry about storing secrets on the disk or persisting any kind of secrets. Once you do this request create async, then what's going to happen is basically you're going to get back an object that we call a key credential. And this is basically an easy way to remember. It's a credential that's based off of keys rather than passwords. And so in this key credential, what you have is that we have a private key, which we never let you really expose because there's no reason to, as you'll see in the next demo. But then we have a public key. And as we said, this public key is what allows you to authenticate to the server using this technology. So in that public key, we're going to go ahead and export that public key from your key credential. And we do that really simple by retrieve public key. It's a very simple method, returns back a blob of data that you'll send up to the server. Now, there's an interesting point here we want to make sure you know about is that when you register a public key with a server, the key thing here is that how you send that data to the server is totally in your control. Microsoft Passport doesn't make you change your transportation protocol to something different. You can use the same protocol that you've been using in your app all along. You're just sending different data using that same protocol. The other point to make here is that because of the security properties of Microsoft Passport, where we can actually use the TPM and hardware bound these keys, that when you have a public key, that you're going to register that public key with the account on the server. Well, what if the user has 4 or 5 devices? The server is going to have to change in the back end a little bit to make sure that it can accommodate multiple public keys because those keys would have different devices, or those devices will have different keys, excuse me. So what we have here is that we need to make sure that on the server back end, what you do is that you make sure that your server can support n number of public keys for each account that is on there. So now let me go back to the application again, and let's look at how we can use Microsoft Passport to sign in. So as you can see, I'm in my app again. I'm going to go sign out. And as you can see, the app, we've retrofitted the app to where it's now Microsoft Passport aware. It can see that I've actually registered using Microsoft Passport, and I'm now ready to actually perform authentication using Microsoft Passport. So what I'm going to do here is I'm going to actually touch on my user tile, and I get the same experience again I have. What's happening here is it's like, okay, I need to get this key in that imaginary container that Anu showed you in that one diagram. And I'm going to need your gesture to unlock that container. So what I'm going to do is go ahead and push. Okay. And then as you can see, my fingerprint unlocked the container. I then actually authenticated using Microsoft Passport. No way did I send a password hash or anything like that, or even provide a password. Let's take a look at how we accomplished that. So in usage, I told you before we had a really simple API set where we have, again, a key credential manager, which is the static class that you're going to use to implement this technology in your apps. In there, we have a very simple method called open async. The account ID that you passed in the create is the account ID you use to retrieve your key credential that you've previously created. So in your app, you'll actually go and say, hey, let's open up the key. And then what's going to happen is that the server is going to send a challenge to the application. Basically, the app will request a challenge data saying, I'm about to authenticate, send me a challenge. The data that the server sends is opaque to your app. Your app doesn't need to know anything about that data. However, the server has a choice to include some security properties in it if they want to, such as a time to live, to make sure that the challenge is only good for so long. You can't just sit there and keep holding on to it indefinitely. So you'll use your protocol to send this challenge. And then basically what you're going to do is you're going to take this challenge and you're going to send it into this request sign async, which is a method off of the key credential that we give you when you open the key. What we do there is that basically when you call the request sign async, not only do we open the container, wait for your gesture, prompt all the biometrics there, but once we get you permission to open the container, get the key, we're then going to go ahead and sign all that data with that key. And then the output of that is going to be a signature of the actual challenge that was sent to the server, sent from the server. So all of the biometrics that you saw, whether it's face, iris, or a fingerprint, all of the on-screen dialogue that you saw, and then actually all of the cryptography that you saw is handled by this one single API, because we've heard time and time again that cryptography is hard, and we want to make this super simple so you guys can use it. Very easy, very simple to use. Once you have your signature, again, using your protocol, you send this signature to the server. Once the server has it, they use the public key that you've registered previously. That public key then is used with the signature and the challenge, and you basically validate that particular piece of data. If a server is confirmed that your private key actually signed the data, then you get authenticated, you issue your tokens as you would normally in your app, and life moves on, and nothing about your app, everything else about your app stays the same. You don't change anything else. So we're only basically changing the authentication mechanism that the app uses. We're not changing anything else, and you're getting all the biometrics and all the cryptography for free. So we have one more scenario we want to show you in the demo, and let me get to that, and that is that we have a delete scenario that we need to show you. So in the delete scenario is that occasionally we get new devices. And so when we get a new device, we might want to take the keys, our Microsoft Passport, off this device because we're going to go ahead and get a new one. So what we need to do there is we actually need to provide a way to where we can remove that particular key from the device. And so in our app here, we've given you an option here where it's basically, it says, forget me. And that's our basic little catchphrase to say, hey, I don't want to use Microsoft Passport on this app anymore. So what we'll do from there is we'll simply say, okay, let me hit forget me. And as you can see, I'm no longer enrolled in Microsoft Passport in the app. The app has seen that I've deleted the key, and then therefore, I no longer have that persisted in the app. And so then if I wanted to use Microsoft Passport again, I would simply follow the provisioning steps that I did previously, and then use that key to go ahead and sign in as we did before. So it's very clean, very easy to use, and let's show that flow of what that looks like. So as you can see here, here's the deletion flow, and it's very similar to the other ones. Again, we're going to use open async, and I'll give you a hint why we're going to do open async is because sometimes you may want to actually inform the server that you're about to get rid of a private key, and that server really doesn't need to use this public key anymore. So this is more of a good hygiene of key management. We want to make sure that the server and the app are in sync as much as possible. So what we do here is we basically say, let's open the key. You'll use the retrieve public key like we did in the provisioning step. And then what you'll do is you'll hold on to that public key, and then you'll call this simple API called delete async, passing in the same friendly or the account name or account ID string that you did when you did create and open. And then basically that will delete the key. Once you confirm that the key is deleted on the local side, then you can go ahead and send using your own protocol, send that public key back up to the server, at which point then the server can manage the public key on its side however it chooses to. It can either tombstone the key and keep it around, or it can go ahead and delete the key, whichever it prefers. So there's a couple other use cases here that we want to touch on. And these use cases are basically, these use cases come into the sense is like, okay, well, maybe I don't want authentication, but I want this idea of consent. And the idea of consent is basically this, is that I'm writing an app, and I just want to make sure that the logged in user of that app is the actual person who's about to do this specific action that the app's going to take place. So the example I give is that you have a doctor in a hospital who's doing rounds for a patient. And we want that doctor to be able to have his device, and he's going from patient to patient to patient, and he's signing in, and he finally hits a patient to where that patient needs a narcotic. And so he's going to, in through his medical app, he's going to sit there and try to prescribe a narcotic for this particular patient. But that's a trusted action. We just don't want anybody doing that because a nurse or an orderly found an open device sitting there ready to do this. So what you can do is you can ask for consent before actually committing that transaction to order that particular prescription. What this will do is, what we've provided is we have a user consent verifier class that we introduced in Windows previously before Windows 10. And in that class, we've actually inserted Windows Hello into that class to where you can get all the biometric framework and support and experience that you've seen here today, but you're not really authenticating to a back-end server of any form of time. You're simply saying, I want to ensure that the logged in user to Windows is the actual same user who's about to perform this action. And in that case, you'll get the same prompt experience, except we're going to basically make sure that the fingerprint or the PIN that they use is the same one that they've enrolled with in Windows. If you are interested in federated, and what I mean is federated is that you have an application to where you use a Microsoft account or Azure Active Directory as your identity to your app, or you're a third-party identity provider where you are going to write applications to where you want others to use your identity, then what we would strongly suggest is that there's a session, tomorrow, session 709, single sign-on with secure authentication. And what that'll do is I'll tell you how you can get this single sign-on experience using the APIs that you've seen today, but in the context of a more federated environment where you're going to allow other people to use these identities and actually or you're going to write an app to where you're going to use someone else's identity. So what we've done here today is we've gone over Microsoft Passport. We've showed you that it's non-phishable because we're getting away from the passwords. It's theft resistant because we have public keys and not password secrets stored on the server. We're using strong user authentication. Not only are we using public key cryptography, but we're also using two-factor auth where it's I have to have my device and I have to know your gesture, whether that be PIN, biometrics of any kind whatsoever. We've also talked about how we've built in support for Windows Hello straight inside Microsoft Passport. And with that built-in support, you write your app one way, and then you get all the flavors of biometric support. So whether you have password, or whether you have PIN, whether you have biometrics such as face, iris, or fingerprint, you don't have to rewrite your app, no code change. You get that all by the 3 APIs that we've showed you today. We've also done a lot of diligence in making sure that these APIs are simple. We really understand that we want to make these simple to use, and we understand that not everybody's a cryptographer and not everybody's a biometric engineer. So these APIs, you have no knowledge of crypto, no knowledge of biometrics, you're good to go. The APIs will just work and they're easily callable. And it certainly is we understand changing a protocol is expensive. Change is expensive regardless. So we wanted to minimize the amount of change that you needed to do to quickly start using Microsoft Passport. So with that change, what we've decided to do is we say, okay, no protocol changes whatsoever. You use your own transport protocol. Just send the data to the server however you need to. And we've tried to minimize the number of server changes that need to occur on the back end. We have a couple resources that we want to share with you to allow you to get started in using these features. Microsoft Passport APIs, these are in our Windows Security Credential namespace. You'll see Key Credential Manager, and pretty much any of the classes that are prefixed with key are these associated particular ones. And these will actually be available now in the build. We have a couple related sessions that should have some sort of data that talks about actually Microsoft Passport and how to manage those. One of them is immediately after this one, which is the managing mobile devices and application enterprise. They may have some actual information there on how, if you're an enterprise and you're seeking this, how you might be able to manage this particular information for your enterprise. And then obviously if you're writing a federated app, or you're an identity provider and you want to federate, then you want to check out session 709, single sign-on with secure authentication. The other thing is Manoush and I will be in the Windows Insider Lounge directly after this particular session. So if you have any other questions or would just like to chat with us, we'd love to talk to you. We'll be in the export zones from 2:15 to 4:15 on Thursday. And when we do a shorter version of this, it's a little bit more, well, it's a lot more compressed. We do that particular presentation on Thursday, 1 to 1:30 in the theater, and then Friday, 1 to 1:30 at the theater as well. And then finally, we want to make sure that if you have any question that we didn't cover either in the presentation or in any of the time that we have allowed to talk to you, that we want to make it easy for you to get your questions answered. So we've created an email address where you can say Ask MS Passport. And with that, please, by all means, send us any question we didn't get to, or if you didn't have a chance to get with us one-on-one, and we'd be more than happy to actually answer those or get you the information that you need. So with that, what I'd like to do is bring Manoush back up on the stage, and we can answer any Q&A that you guys may have.
So you touched on it briefly. Is this going to integrate with Active Directory? Like plug in the enterprise?
Can you hear me? Yes.
Log on domains?
That's correct. The answer is yes.
Yes.
You mentioned talking to a server to interact for authentication.
Yes.
What if you just want to protect your app locally with no server interaction? How would you use this to do that?
Protect your app locally. In what context?
Say you write tax software and you want to encrypt the tax data on the local drive.
Okay, so the question, to encrypt, this doesn't provide encryption. This is just an authentication mechanism right now. So basically, is if that tax data, if it was stored on a server, per se, then what that you could use this technology for is that instead of typing in a password to get into your app to access the data, you would use this technology over a password, so that way you would authenticate with the server and then you could pull your data down.
So there's no way to get a private key back for you to do your own encryption on a file?
Correct. This is not for encryption. This is strictly a signature.
Yes, go ahead, please.
Yeah, it's not unique to what you're doing here, so I wish the same thing. But about 20% of customers would probably use 1, 2, 3, 4. That means you might want to turn it off in certain situations. Is it possible to turn off a PIN option for this Windows Hello in certain high security situations?
In the release that is coming, PIN will be required to set up Windows Hello. However, we do provide ways for enterprises to manage the complexity of the PIN. So they can basically make it such that the PIN is more complex and it could be alphanumeric. The session that Mike said after this actually deep dives into stuff like that. So you can check it out. Yeah.
So,
Over there. Go ahead, please.
Yeah, for the face recognition password, how did you measure the failure rate for the false positive?
So I think for that, I would like you to send an email to MS Ask Passport question. The data that we use is changing, and I want to provide the most accurate one. If you send us a question, I'll send you the data sample, but it's more than 30,000 samples that we use over like 4 million plus combinations. But if you send me the actual email, I'll provide you the most accurate answer. Yep. Go
So
ahead,
what kind of control do you have over what are the allowed authentication mechanisms that are protecting the key, and what kind of extensibility is there? Given that the FIDO definitions allow custom providers, you can say, hey, a server will only accept an assertion if you do X, Y, Z. And suppose I have a strong scenario where I need to use a custom authentication mechanism. like an NFC device, and I want to say, look, I'm going to require the scan here, and only if that one works,
Yep.
Will my server accept it, right?
Yep, absolutely. It's a great question. And I want to break it down in two pieces. You brought up two different topics here. The first one is about the gestures that are allowed for the user. As I mentioned, FIDO 2.0 is a new working group within FIDO that has been created. We're actively looking at a similar problem and how to basically close down on the policies and gestures allowed. So that's a work in progress, and there's a team within that group that is looking at it. As I mentioned, once we have the specs finalized, we make sure that the Microsoft Passport will be reference implementation for that. So that's the first part of your question, but yes, absolutely, we have to address that. The second piece you asked about, okay, so if I have other devices that have my private key, how would Windows integrate with them?
Not quite. I'm still relying on the TPM to protect the key. It's just I need a different mechanism instead of a PIN or a biometric to unlock that key. So it's extensibility in some, like what?
So if you remember at the beginning of this, I discussed the integration with Windows biometric framework. So if something that is integrated with it, then it will be supported outside that.
So I want to go lower level than that. Not biometric. We want to have another physical token device and say, look, if someone who's in possession of this token, I'll write, I can use the NFC APIs to do X, Y, Z. I will do my own authentication and say, yes, the user, this is the correct user. Unlock the TPM, go.
I see. The thinking for the most immediate release is that whatever gesture we discuss here are the only supported ones. We will support scenarios where the gesture that you mentioned and the key are in a remote device. That is also something we're looking at. But a combination where the gesture comes from a different device and the key is in a TPM, that's not something that we will immediately support. Question over there.
Well, actually, that answered half my question.
Okay.
The other half of my question is also on the local scenario. For example, let's say that I have an external product like a disk drive, and I want to tie into this system for user authentication. So you can't just take the drive and plug it into any random computer and access it. You plug the drive in and want to leverage this method of authentication before allowing access. Is there any method to do that for a local device rather than through a server?
So when you say local device, are you stating that this is almost like a hard drive that you want to authenticate?
Correct. External USB external hard drive, for example.
The framework that we discuss here is basically providing crypto primitive, and we've also done the work to tie up the Windows logon with it. So if their authentication path, none of this exists, it will not work. In other words, let's say that external hard drive, let's say had some keys that are known by Microsoft account or Azure AD. Had that been the case, if you plug it into, and in near future, what we could do is to make sure that we can access that key over USB, and as if it's something locally, that's basically the remote authentication scenario. However, if you want to perform authentication to the hard drive, that's not something that will be supported by this immediately, unless the hard drive comes up with its own custom application that leverages Microsoft Passport. Otherwise, it would not be supported. Question over there?
Yeah, I've just two questions. One is this tied to needing a TPM device, or are we going to be able to support this on devices that don't have a TPM? And also things like removable smart cards, would that be supported?
So the second part of your question, so I'm not sure if you're familiar with the virtual smart card work that we did in 8.1. This framework encompasses that. So it is the next thing compared to that. And it will basically, whatever we did in virtual smart card is now ported to Microsoft Passport. The first part of your question I didn't quite follow. Would you mind repeating it?
I was just saying, are you tied to needing a virtual smart card on a TPM, or will this work on hardware that doesn't have a TPM?
I see. The Microsoft Passport technically could work without a hardware. In that case, we'll basically roll back to software. However, we do provide policies for enterprises to require hardware, in which case the key creation will simply fail. So that's something that enterprise can manage, but for consumer, we don't require it by default. Sure. Next question.
Does the Intel world-facing 3D camera support Windows Hello?
Sorry, are you asking about the device support?
Intel world-facing 3D camera support.
The
rear-facing
rear-facing
camera. So as far as it's an IR camera that meets our specs, yes, the answer is yes. No, yeah.
On the slide, JavaScript API will be supported some browsers. It is only Microsoft browser or Chrome or something else.
So the question is about JavaScript API and what browser will support it. As I mentioned, we're part of FIDO, and we want to make sure that the JavaScript API that we implement in Windows 10 will be based on the standards that are accepted by other browsers. So it is a goal for us to make sure whatever we come up with actually works with other browsers as well.
I think one in the middle here.
Yep, go ahead.
Yep.
Let's say my device is stored as a user. I can go online and validate and try to know on that device.
So the question is, if the user loses his device, what's the story? With the passwords, you can simply change your password, but what about Microsoft Passport? The answer to that is it is something that the server can provide. Imagine there is a portal for you to go and report that a device has been lost. The server has a notion of what keys were stored on that device. So at that point, they can simply remove the key associated with that device from the set of keys that are associated with that user. So if somebody has access to your device and for some reason they know your PIN, they cannot use it because the server rejects it.
Is there a device ID or something that ties that to the device?
So the question is there any device ID that maps the keys stored on the server with the device? The answer is yes and no. Yes, in the sense that we have capability in Windows 10 that allows the server to verify that the key is bound to a TPM. We call it TPM key attestation. No, in the sense that, and I think I alluded this in one of the slides, we want to make sure that the servers cannot track users' kind of experience and activities. And so what we do is actually we create different type of attestation for different identity providers. So two identity providers cannot tie you to the same device. And so it is yes in the sense that we support attestation. It is no that we can't tie it together.
But if you use 3 different devices to access the same site, if you lost one, you might have to delete them all to make sure that
Oh, I see what you meant. Yes, the browser has enough notion to identify your device to you in a friendly way. So you can say, well, it was my laptop that was stolen, and they can provide you option. Was it your laptop? Was it your phone? Was it your PC? So there is that thing that... this is something that the browser can decide on. Well, we don't have the browser history yet, but the idea is that you get some kind of identifier and maybe some friendly name that the user can pick, and that would be the way to track it. Yeah.
What the Microsoft Live server is going to do in that case? Because you're talking about a notional server, but in that case, there's already stuff out there that I assume is going to federate with Microsoft Passport, which is traditional Microsoft Passport. So in that case, what's going to happen when I lose my tablet, but I still got my service?
So I think if going back to the answer earlier provided, if there is a browser, if there is a web portal for you to go and report that you lost your Surface in this case, what the server can do is to, because it knows which keys was stored on your Surface, it can simply remove that from the list of trusted keys for you. So you can continue using your other devices, and this is one nice thing about Microsoft Passport. It allows you a per-device kind of revocation where you don't have that with the password. If you lose one of your devices and you use your password on it, you have to change your password. With Microsoft Passport, all you have to do is to report the lost device, that key gets deleted, the remainder of the keys will continue to work. And as Mike said, because every device has a separate key, then your other keys are still safe, and you don't have to change them.
So just to finish that up, so what Anish is alluding to here is that this is a server experience because at that particular point the device is gone, right? So this portal experience that we're describing is something that you have to think about as I've lost a device. And so that particular case, you're not really tracking the device for the purpose of, oh, I want to be able to start, trying to collect ad data or something like that. It simply says is that, oh, hey, you registered this public key from device A. If you ever lose device A, then that server or that identity provider would basically say, okay, here's our portal. If you lost my device, then you tell us the name of your device or you give us some sort of hint of what device you lost. And then we on the back end can say, okay, that public key is persona non grata at that point. So that's kind of the experience when you create a lost device experience there.
Question over there.
For the Active Directory stuff, is there a new server required or how does this interact?
That is correct. There will be new server required depending on it's a fairly complex conversation to have. I think I would like you, if you can send an email to ask MS Passport.
Yeah.
We'll definitely provide you with all the contents. I apologize, I don't want to miss your question. Just want to make sure you get the right answer. Yes, go ahead, please.
It's along the same lines. My question is associated with the enterprise and the offline access.
Mm-hmm.
So when the Windows Hello is used, what kind of data you cache on the system so that the users are allowed when they are not connected to their AD or to their whatever Microsoft Passport servers are?
That's correct. Okay. Yeah. So do
you want to take? So that's an excellent question. So I don't know if the mics are working. So basically, the question was in the offline scenario, how do you accommodate for the offline scenario when the servers are not online? And it basically, again, this is a concept that the identity provider owns in the sense that we all know the basic OAuth handshake and how this works, and you get back a token, right? And so some of these identity providers give you a token that has some sort of time to live, which basically is like, as long as you have this token, then if you're offline, they'll still reuse it, but most of the time they'll reuse it in order to try to bootstrap another logon when you first come online. So this is really, Microsoft Passport doesn't have any notion of online, offline. It doesn't care in that sense because it's expecting an online experience. What you do after you've done the initial authentication is totally in the hands of the identity provider, and they can provide a better experience for an offline sign-in versus an online sign-in.
But your Windows Hello is part of the authentication into the system, right? So
Windows Hello unlocks basically Windows Hello unlocks is the gesture used to unlock access to the keys that are stored locally. The gesture itself is never sent to the server. Yeah.
So there are keys that are stored locally.
Mm-hmm.
Are these just you stored something like NTLM hashes were stored?
No, they're actually RSA 2048-bit asymmetric keys that wrapped in TPM. So that way, if you try to move the key to another device, it's not going to work because the TPM can't understand it.
Thanks.
Yep.
One question over there.
Yeah, can you set up multiple pins on the same device so that basically if you had kids that use the device, you could grant them access to Facebook and not Netflix?
So the question is, can you set up multiple pins on the system? And the answer to that is, there is that possibility, but not in the concept that you had in mind. It is more between separating your personal stuff from work stuff. So that's possible. There will be two different pins for them. The scenario you mentioned, the way we recommend that you do it would be that to set up an account for your child and they can have their own pin. That's our supported answer for the question.
How is RealSense making your solution better? Is this just about better spook protection? What's the value that RealSense brings if I have that in the hardware?
That's a great question, and I would like you to send an email to the Ask MS Passport. I don't have the right answer, that's why I don't want to dodge your question.
Can you speak to the camera adoption, like the hardware? Who are you working with in the hardware industry to have cameras to support IR? I'm not as familiar, but I make the assumption, and you correct me if I'm wrong, that this camera in my pocket is not going to work.
So what we had in the slide is the official answer we can provide at this point. The more details on this will be coming soon, so you need to stay put.
But you are correct. The camera in your pocket most likely will not work because it relies on infrared technology.
Right, and so meaning, and so I'll ask one more time, you can't share what vendors you're working with? Okay.
Question.
So on the file specs, set of credential is assigned to some application ID, like the FID on a store or a domain for a server. Is this the same with Passport? Do you have some ID that you have to provide?
So the way we looked at this is we wanted to make sure that the data that is stored with the key are the things that are immutable. So we want to make sure that we don't store things that needs updating later on. Domain name is one thing that we do support. Mike, please correct me if I'm wrong here. Passing domain name for the key. Do we support that in?
For the ID, sorry, there's an ID part.
The ID part is just an opaque part that the caller passes, and it's just their notion of how they track the user.
So, yeah, the ID part is just, think of it as entropy. There's, underneath the covers, there's a lot more stuff that goes into the key. But think of it as user-provided entropy that allows you to ensure that it's unique. So basically, if you just had that and you looked under the covers, the key name is going to be something totally unintelligible to you. But because you've provided this string when you do your creation, then we can use that in addition to the algorithm we use to create a key name to make sure that that's the only key that would ever have that name.
So, but the spec suggests that, for example, Android apps should use the app ID and browsers should use the domain name. So is there like a notion that...
Are you talking about like origin?
Yeah.
Okay, so for what we use with this particular API set, we use the app ID. So that's,
I think I know the answer. Let me take this. So I believe where you're getting at things like facet ID, ability to map an app to a domain name. Exactly. And this is, again, something that the FIDO 2.0 is looking at as we speak. And we'll wait until that decision concludes to come up with an answer. So for now, the only isolation we provide is, because we only support apps creating keys in the Microsoft Passport, is basically isolation between the apps. We still haven't enabled the browser scenarios to create keys. And once we get to that point, hopefully FIDO 2.0 will be settled down. And so there will be a way to kind of address what you just brought up. It is absolutely something we need to feel. Yeah, sure. This question over there.
Yeah. For the a pin makes it very easy to set up Windows.
Yep.
Part of GUI. What's required for that step to show up? Does it have to have the presence of a TPM? Does it have to have a WPF hardware?
No, the good thing about that is because that's a consumer side and we don't have any policy that says only use hardware, it actually works no matter what. If there is a TPM, it will leverage it. If there's no TPM, we will simply roll back to software. So that UI is always shown to the user. That would be the answer.
I believe you have to be online, though.
Of course.
Yeah.
Yes.
So how does an app know that the password is based off of software or hardware root of trust?
You.
That's a critical thing. I mean, I would want my trust in software based if I have some secure app.
Sure. So we didn't highlight it in here, but if you go look at the actual API namespace, we have a way to get attestation data. And that attestation data you can use that attestation data to see if you actually provision the key in TPM versus it's not.
And then, using TPMs, what about like discrete TPMs have more performance on a lot of consumer-grade,
Sure.
business-grade machines?
Yes.
And I mean, because that's, I mean, it's making a pretty wildly strange compressor to take 30 seconds or 40 seconds to generate 24 to 50 TPMs.
So actually, we did a lot of research on that, and one of the things that we have implemented in Windows 10 is what is called the pre-generation pool. So what we do is we actually start creating keys ahead of time, and we have a pool of keys ready for the apps to be using it. And every time an app's claim one, we try to create another one and have it ready. So with that, we've achieved a performance that seems like really fluid. Yep, one question over there.
Is there any component for server authentication to make sure you're hitting the right endpoint?
So the question is server authentication. And one thing that Mike brought up is Microsoft Passport and APIs are basically crypto primitive. As to what you do with it and how, excuse me, how we use it for talking to a server is totally dependent on the application. Obviously, we recommend using SSL and things like certificate pinning and things like that, but this is something that the application has to decide. Microsoft Passport don't care. That's correct.
Yeah, it's the freedom for you to choose how you want to ensure that you're hitting the right endpoint. Any others? Okay.
Thank you guys.
Thanks,
for your time.
guys. Appreciate it.